Imagine a seemingly minor programming oversight. Maybe it's just a missing closing tag in a line of code.
Yeah, or like an unchecked input field on a website.
Right, or even a forgotten piece of documentation just tucked away somewhere. Now, picture that tiny error as, the crack in a dam, silently growing.
Until it leads to, well, disaster. A catastrophic data breach leaking millions of records.
Or a widespread outage grinding a whole company to a halt.
Or worse, a critical system completely hijacked.
And this isn't just theory, right? This is how real-world hacks actually happen, often.
It really is.
So what if I told you that understanding how to build software is actually the best way to figure out how to break it?
And, more importantly, how to protect it.
Exactly. Welcome to The Deep Dive, your shortcut to becoming truly well-informed. Today, we're unpacking a really crucial topic for anyone in the tech landscape, programming for security professionals.
Yeah, we're drawing insights directly from a key text. Hands-on Ethical Hacking and Network Defense, 3rd edition by Simpson and Antill.
And our mission, it's simple, really, to show you why getting a solid grasp of programming isn't just for the developers.
Right. It's actually an indispensable superpower for ethical hackers, for network defenders.
And really, anyone aiming for leadership in information systems, computer information systems, or IT.
And hey, as we journey through these insights, if you find this deep dive valuable, do us a huge favor.
Yeah, please like, subscribe, and share this with anyone you think needs to level up their tech game.
That way, you'll never miss the insider tips that could, one day save your career. Or maybe even an entire network from a critical vulnerability.
Okay, so let's dig into this core connection then.
Yeah.
Why exactly are programmers, or at least people who really get programming, why are they basically the frontline guardians of our digital world?
Well, it's precisely because so many attacks, the ones we see hitting operating systems and applications, they stem from what you could call the unseen vulnerability.
Unseen vulnerability.
Okay. Yeah, think of it like building a house, or maybe a skyscraper. If the architects are programmers, don't fully understand the physics, the stress points, potential weaknesses.
How things connect.
Exactly, how different materials interact. The structure they build might look fine, on the surface.
It looks solid.
But it's inherently vulnerable right from the blueprint stage. Poor programming practices are, well, they're essentially direct pathways for exploitation.
And it's kind of astonishing, isn't it, how many computer science programs in colleges, while they teach programming really well, they don't always teach it with security explicitly baked in from the start.
That's a huge point. It absolutely creates these gaps that, ethical hackers then have to find and hopefully help patch.
So it leaves these vulnerabilities just sitting there.
Pretty much. And, at its heart, all programming, doesn't matter which language, it boils down to some really fundamental concepts.
Okay.
We can think of them as like the basic moves.
Yeah.
Branching, looping, and testing.
Yeah.
Sometimes called BLT.
KLT, okay. Easy to remember.
Right. Branching is your if-then-else. Making decisions, controlling the flow.
If this happens, do that. If not, do something else.
Exactly. Looping lets you repeat tasks. Processing a list, going through data.
Over and over.
And testing, that's the conditions. Does the loop continue? Which branch do we take?
Right.
Now, for a security pro, understanding these isn't just about writing code that works. It's about spotting, say, a loop that never ends.
Ah, denial of service right there.
Precisely. Or maybe a branching statement, an if statement, with an unexpected else's path that accidentally grants access it shouldn't. That's the security angle.
It's like building with Legos. You've got the basic bricks, how you snap them together, how many times you repeat a pattern, where you put a door versus a window that defines the whole thing.
Good analogy.
But imagine someone who knows the subtle weaknesses, like how a certain brick connection isn't quite stable, or a flaw in the design means you can add one tiny piece and make the whole thing just crumble. That's the algorithmic insight for security, right? Understanding the algorithm, the step-by-step process to predict how it behaves.
And crucially, how it might misbehave.
Yeah. Which leads us right to the hidden enemy. Bugs.
Bugs. Simple mistakes in code. And poor programming. Well, that makes systems susceptible. It's a direct pathway for bugs to become exploitable vulnerabilities.
A tiny bug looks innocent.
Becomes a wide open door for an attacker.
So if we want to keep those doors closed, what's one of the most critical things, something that's often overlooked in programming for security?
Oh, that's easy. Documentation.
Documentation, really.
Absolutely. Proper documentation is often the unsung hero. It helps the original programmers understand their own code, maybe weeks or months later.
Okay, that makes sense. You forget your own logic.
Everyone does. It helps other team members understand it too, which is vital.
Right, collaboration.
And most importantly, when you are hunting for those tricky bugs or trying to patch a vulnerability under pressure, clear, concise documentation, it makes finding and fixing them so much easier, exponentially easier.
So it's like having that detailed blueprint you mentioned, an up-to-date map of the defenses.
Exactly. Instead of, a scribbled note on a napkin from 2 years ago, it's the difference between knowing exactly where to look for a weakness versus just guessing.
That blueprint analogy really hits home. A design flaw can just doom the whole thing. Okay, so if understanding these core concepts is critical, where do we start with specific languages? What's the absolute bedrock?
Great question. We really have to begin with C. It's the foundation stone.
C.
Developed by Dennis Ritchie, Bell Labs, way back in '72. C++ is basically an enhancement, builds on it.
And why C for security folks?
Because it lets you understand the low-level workings of so many systems. I mean, think about it. A lot of operating systems, or at least critical parts of them, written in C or C++ nor.
Right? Down close to the metal, so to speak.
Exactly. And when you look at a basic C program, you see how it works. Loading libraries, declaring variables, numbers, text strings. You learn the basic math and logic operators. The ANDs, ORs, not Ts, that control decisions.
And for a security person?
Well, imagine just one misplaced operator in, say, an authentication check. That could potentially open a huge backdoor. It's that fundamental.
Wow.
And those core BLT concepts, branching, looping, testing, they're all there in C. Implemented using functions, different kinds of loops like while, do, for.
Okay.
Knowing C is crucial because it helps you understand how apps interact directly with the operating system's memory.
Memory management. That sounds important.
It is. This is where you really start to see how things like buffer overflows can happen.
Explain that quickly.
Sure. A buffer overflow is when a program tries to shove more data into a temporary storage buffer than it was built to hold.
Okay. It spills over.
It spills over right into adjacent memory. And that can overwrite critical program instructions or data.
Which an attacker could use.
Exactly. Attackers leverage this to inject their own malicious code. Things like exploit shellcode, small bits of code designed to give them control of your system.
Got it.
So understanding that fundamental interaction, how C handles memory directly, that's key to spotting weaknesses in compiled software. And it's fundamental for OS hardening.
OS hardening, basically making the operating system tougher.
Precisely. Making it more resilient against exactly these kinds of attacks.
Okay, C is foundational. What's next? You mentioned websites earlier, so HTML.
Yep, let's talk HTML. Now, it's often mistaken for a programming language.
But it isn't, right?
Not really. It's a formatting language. It structures content on the web. It's the foundation of web development, but it doesn't have the same kind of logic, loops, branches.
So if it's not programming like C, why does a security pro need to understand HTML? What's the angle there?
Well, what's fascinating is it's not about you needing to write web pages from scratch.
Okay.
It's about being able to read HTML files and recognize when something looks, well, suspicious.
Reading the source code of a page.
Exactly. Think about inspecting an email or a web page. Understanding HTML lets you see behind the visual display.
What kind of things are you looking for?
You're looking for things like a tag, a link. The text might look legitimate, say, click here for your bank, but the actual href attribute, the destination, it silently points you to a phishing site.
Sneaky.
Very. Or maybe script tags. If the website doesn't handle user input properly, an attacker might inject malicious client-side code.
That's cross-site scripting, XSS.
It's XSS. It runs right in the user's browser. So knowing the basic anatomy of an HTML page, the common tags for formatting, links, scripts, it's absolutely crucial for web security.
So you can spot those hidden redirects or injected scripts.
You got it. It lets you peer behind the curtain and see what a website is really trying to do, spot those vulnerabilities that are invisible to the average user.
Makes perfect sense. It's like reading the real ingredients, not just looking at the pretty package. Okay, next up, Perl, often called the Swiss Army knife.
Yeah, that's a common one.
Used for good and bad.
Perl, practical extraction and report language. It's incredibly powerful. And yeah, here's the twist. It's used heavily by both hackers and security professionals.
How do the bad guys use it?
Malicious actors use it to create automated exploits, build bots for things like phishing campaigns, automate scraping data from compromised systems.
Wow.
I've even seen seemingly simple configuration files written in Perl launch really sophisticated attacks because The defender maybe didn't grasp the full logic.
Okay, but the good guys use it too.
Oh yeah, defenders use it all the time for automating repetitive tasks. Parsing huge log files to find anomalies, analyzing network traffic patterns, security monitoring, things that would take ages manually.
So it's a workhorse for defense automation.
Totally versatile.
Yeah.
And its syntax, it's quite similar to C, so if you know C, picking up Perl is generally faster.
Right.
Its command line tools let you do rapid prototyping, quick analysis, and its strengths in, again, branching, looping, testing, plus its operators. It makes it fantastic for writing security scripts.
So knowing Perl helps you.
It helps you interpret and compare the hacking tools you might encounter. You understand why they work, not just that they work.
Deeper understanding.
Right. And you can use current network and security software more effectively, or even build your own custom scripts to automate your specific defense needs.
Very powerful. Okay, shifting gears a bit. Modern applications often use a different approach, right? Object-oriented programming, or OOP.
Yes, OOP. That's a major paradigm. It's an alternative and now very common way to create programs.
What are the core ideas there?
Its main components are classes and objects. Think of a class as the blueprint. It holds data definitions and functions or methods.
Like the design for a car.
Exactly. And an object is the actual instance created from that blueprint, the car rolling off the assembly line.
Got it. And security testers use OOP languages.
Many do. For instance, Ruby is popular. It's object-oriented and actually pretty similar to Perl in some ways.
So why is understanding OOP itself important for security?
Because so many modern applications are built this way. You're not just looking at flat lines of code anymore. You're looking at how these different objects interact with each other.
Okay, interactions between components.
Right. And knowing OOP concepts like, say, inheritance.
Where one class gets properties from another.
Yes. Or polymorphism, where different objects can respond to the same command in their own specific ways. Understanding these helps you dissect complex applications.
How does that help find vulnerabilities?
Well, you can identify where data might be improperly exposed because of weak encapsulation. Maybe private data is accessible when it shouldn't be.
No.
Or you might see how an attacker could exploit a flaw in an inheritance chain to maybe gain higher privileges within the application.
So it's about understanding the architecture.
Exactly. It's about moving beyond just surface-level patching and understanding potential architectural flaws. Without that OOP understanding, you're often just trying to secure a black box, guessing where the problems might be.
Okay, that makes a lot of sense. So we've covered core concepts, C, HTML, Perl, OOP. Let's bring this home. How to bridge this knowledge to action.
Right.
Especially for our listeners, maybe students heading into the workforce from programs like, say, those at the Dr. Sam Pack College of Business at Tarleton State University. What are the real practical takeaways for careers in MIS, CIS, or IT?
Okay, the big one is this. Understanding programming isn't just about becoming a coder. Not necessarily.
More than that.
Much more. It's about developing the critical thinking skills of a defender. It's learning to think like a hacker by understanding how code can be manipulated.
So you can anticipate attacks.
Precisely. Which in turn helps you act like a guardian by implementing smarter, more robust defenses. And this mindset is exactly what we try to foster for students preparing for career success and eventually leadership roles in tech.
And the real-world impact, you can really see it, can't you? This programming knowledge connects directly to needed skills. Like, take a course such as BCIS 4342, Ethical Hacking and Network Defense. The goal there is learning to find vulnerabilities using hacker techniques to improve defenses. Programming knowledge is like a superpower in that context.
It really is.
With this foundation, you're just much better equipped, right? First, you can identify core concepts in network security and penetration testing with real depth.
Yep, not just surface level.
You'll recognize vulnerabilities in systems and apps because you understand the underlying code structures that allow that.
You see the root cause.
Yeah. You can interpret and compare hacking tools much better. You get the why behind them, not just the what.
Which means you can adapt faster when new tools or techniques pop up.
Right. And you can describe and implement OS hardening best practices with genuine insight. You're not just following a checklist. You understand why each step matters.
Making systems truly resilient.
And you'll use current network and security software more effectively. You might even gain the ability to create your own bootable security toolkits for different operating systems.
Which is a hugely valuable skill out in the field. Seriously practical.
Plus, knowing programming helps you understand security reporting better, right? Knowing what technical details are crucial to document about a vulnerability.
Definitely. The how, the why, the impact,
Mhm.
all from a code perspective, it makes your reports much more actionable.
So all this makes you a much more valuable asset when you're entering the workforce. It supports lifelong learning
Which is critical in tech.
and helps you pursue those leadership opportunities down the line. It really empowers you to be proactive, not just reactive, in cybersecurity.
That's the goal, equipping you not just with facts, but with that deep understanding that fuels critical thinking, problem solving, and continuous growth throughout your career in MIS, CIS, and IT.
Okay, so let's recap. We've basically explored why getting a foundational understanding of programming languages like C, HTML, Perl, and those OOP concepts is absolutely essential for anyone serious about cybersecurity.
Yeah, from understanding how vulnerabilities are born from, frankly, poor coding, to actually leveraging scripting languages like Perl for active defense. Programming really is the bedrock of network security.
Remember that opening scenario, that tiny coding error leading to potential disaster. Now you understand that by grasping these programming principles, you're not just understanding the problem.
You're becoming a key part of the solution.
Couldn't have said it better. Thank you for joining us on this deep dive.
And if you found this useful, please hit that like button, subscribe so you stay informed.
And definitely share this episode. Help others strengthen their digital defenses too.
So here's something to think about. As you look at the digital world around you now, how will your newfound understanding of programming change the way you approach security?
Yeah, what new vulnerabilities do you maybe see or look for that you didn't before?
Think like a hacker. Act like a guardian.
Until next time, keep your systems and your ethics strong.